We've talked a little bit about this in class already. We've done some examples of this, but the basic idea when you're going to rearrange equations is to do the opposite to what's already done. So if something's multiplied, we divide. If something's divided, we multiply. If something's added, we subtract. If something's subtracted, we add. But the challenge that a lot of people struggle with is, what do we do first? Like, do we divide first, or do we add first, or whatever the case may be? Here's a simple rule of remembering what we do first. We do first what is not attached. And we do second what is attached. So how do we know what is attached and what's not attached? Well, I define what's not attached is something that's added or subtracted. I define something that is attached as something that's multiplied or divided. So if you look at that first general equation here, AXY plus C equals D, those could be any variables in physics 20 or physics 30 or third-year university physics. It doesn't matter. Any variables. In the end, we would say the A, or sorry, if we're solving for X here, the A and the Y are attached because they're multiplied, and the C is not attached. Does that make sense? That's where we got to start, right? What is attached and what's not attached. The A and the Y are attached, and the C is the A and the Y are attached, and the C is not attached. If we can't get that, if we don't understand that part of it, then we're not going to understand the rest. So we got to make sure that we get that. If you don't, then make sure that you let me know so that we can spend some more time on that. Okay, the general rule of thumb is to get rid of what's not attached first. Now, there are a couple other little small rules that we got to pay attention to as well, but that's the general rule of thumb. Get rid of what's not attached, and then get rid of what is attached. Okay, that's good news. If we know what's attached and what's not attached, now we know what order to get rid of it in, right? And we know what to do if it's multiplied, divide, if it's added and subtracted. Let's take a look at one quick little example about, not about how to rearrange it, but just talking about what's attached and what's not attached here. This is on the sheet that I gave to you as well. So D is equal to VIT plus 1/2 PT squared. We see that one a lot in physics 20. We will occasionally even see that in physics 30. We would say if we're solving for A, I mean, we could solve for any variable here, but let's say we're solving for A here. We would say that the half in the A in the T squared are attached because they're multiplied by A. We would say that the VI and the T are not attached. Sorry, the VI is attached to the T, right? VI is attached to the T, but the VI is not attached to the A. Make sense? The half and the T squared are attached to the A. The half and the T squared are not attached to T or to VI. So if it's multiplied or divided, we say it's attached. If it's added or subtracted, we say that it's not attached. Get rid of what's not attached first. So this is the first rule that we have here, the first of the three really, really, really important rules. Get rid of what's not attached first. So if we're solving for, in this case up here, if we're solving for A, then we would get rid of what first? VI and the T, right? Because they're not attached. If we were solving for VI, we would get rid of what? The 1/2 AT squared, because that's what's not attached. In the top equation up here, this general equation, it's not even really a physics equation. If we're solving for A, we would get rid of what first? The C. If we were solving for C, we would get rid of what first? AXY, because the AXY aren't attached to the C. They're added to the C as opposed to multiplied or divided. So get rid of what's not attached first. And how do we do that? We do exactly the opposite as to what we have already done in the equation. So if in this one, we're getting rid of the A, the X, and the Y, because they're added to C, we would get rid of it by subtracting it on the other side. If we were getting rid of the 1/2 AT squared here, it's added to VIT, so we would get rid of it by subtracting on the other side. Do exactly the opposite. If, let's say if we were getting rid of, solving for A here, okay, how do we get rid of the C? Well, it's added to AXY, so we would get rid of it by subtracting. It's not attached. Get rid of it first. Do it by subtracting. Solving for A over here. How are you going to get rid of the VIT that's not attached? Take it over by subtracting, right? Then you get rid of what is attached. And sometimes this gets a little bit trickier here, getting rid of what is attached, because there tends to be more variables here. So in this bottom one, solving for A here, get rid of the VIT first by subtracting. The equation ends up looking like this. D is equal to VIT plus 1/2 AT squared minus VIT on both sides. Okay. On this side, the VIT disappears because VIT minus VIT is 0. On the left side, it becomes D minus VIT equals 1/2 AT squared. Now let's get rid of what is attached. What is attached here? The half m t squared. So they're multiplied by A. How are we going to get rid of them? By dividing. Get rid of what is attached by doing the opposite. Multiplied. Now let's make sure we divide them. Then we got to get rid of squares or square roots. Remember those 3 steps in that order. Okay, get rid of what's not attached, get rid of what is attached, get rid of a square or a square root here. Let's go back to this equation for a second and say that I'm solving for t for, actually, let's not use that one. Let's use this one. VF squared is equal to VI squared plus 2AD. Let's say we're solving for VI. We're solving for VI here. Get rid of what is, get rid of what's not attached first, right? What's not attached? 2AD. How do you get rid of it? It's added to VI squared, so let's get rid of it by subtracting. VF squared minus 2AD equals VI squared. Get rid of what is attached. There's nothing attached. Get rid of squares or square roots. So what are we going to do? Take the square root of both sides. It becomes the square root of VF squared minus 2AD equals VI. Really, we square rooted that right-hand side. We just didn't show the work there, right? Now you can see some notes at the bottom of the handout that you have, 3 separate notes that talk about things that don't happen all that often, but that we still have to deal with, okay? I want to do a couple little examples of the basic rules, and then we'll start talking about those little notes that are kind of a twist on the basic rules here. So let's take a look at this equation. You haven't done this one yet. You may have in Science 10. That's okay. Doesn't really matter. I mean, I can give you an equation from second year university. It wouldn't matter. We can still rearrange it. You want to solve for V here. Okay, you want to solve for V. What's the first rule? Get rid of what is not attached. Is there anything that's not attached here? Okay, nothing not attached. So what's the second rule? Get rid of what is attached. What is attached? 1/2 of the m. So how do we get rid of the half of the m if they're multiplied by v squared? We divide it. So we're going to say on the left-hand side here it becomes ek over 1/2 m equals v squared. Now we have to go with the third rule, which is get rid of squares and square roots. Do the opposite. So in order to get rid of the square, we're going to square root it. It's going to become square root of ek over 1/2 m equals v. Would it be okay, by the way, to write it like this? Just change the order of it up a little bit there? Sure, it's exactly the same thing, right? Right, if A equals B, then B equals A as well. Right, let's take a look at another example here. Here's another one that you've never seen before. You'll see it later on this year. FG is equal to GM1 M2 over R squared. Solve for M2. Get rid of what's not attached. Rule 1, get rid of what's not attached. Is there anything not attached here? It's all attached, right? Okay, so rule number 1 is done. Rule number 2, get rid of what is attached. What is attached? GM1 and the R squared. You got a couple of options here. You could say that the R squared is divided, so you could take it to the other side by multiplying. right? And then the GM1 are multiplied, so you take it to the other side by dividing. Does that make sense? Good. Now, anybody see another little option here? You just the correct answer looks a little bit different, and the method is a little bit different, but we could say that GM1 over R squared is multiplied, the whole thing is multiplied by M1. So we could take that whole thing over by dividing. FG over GM1 over R squared equals M2. That's exactly the same thing. Now, it's actually less steps, but it's uglier, isn't it? It's uglier when it looks like this. So whatever one makes you comfortable, okay? Personally, I'd probably go with this, even though it's an extra step. It's probably easier to plug into your calculator than the other one is. All right, let's look at those little notes at the bottom of the page. If several terms appear in brackets, and trying to solve for something that's inside the brackets, get rid of everything that's outside the brackets first using the above rules. If several terms appear in brackets and you're trying to solve for something that's outside the brackets, treat what's inside the brackets as one term and get rid of it using the above rules. And if something's on the bottom and you want to solve for it, then you got to get it to the top. Let's deal with the third rule first, because that's probably the easiest of the three. Let's say we've got, once again, F is equal to GM1 M2 over R squared. You want to solve for R. Okay, what do we got to do first? First, we got to get it to the top. How do you get it to the top? Multiply, right? It's divided, multiply. So let's multiply both sides by R squared. Good? Now we've got a problem that we can deal with using those three basic rules. Because now that R is on the top, we get rid of what's not attached, we get rid of what is attached, and then we get rid of squares and square roots. So let's, nothing not attached. There is the F that is attached. Let's divide by that. And then we're going to square root both sides. So it becomes R is equal to the square root of GM1 M2 over F. So three basic rules: what's not attached, what is attached, squares and square roots. But if you got something on the bottom and you want to solve for that, you got to get it up to the top first and then follow those three basic rules. All right? What if you got something like this? What if you get something like this and we want to solve for, I don't know, let's say VI. It's inside brackets, right? We got to go to those notes at the bottom of the page. If several terms appear in brackets and you're trying to solve for something that's inside the brackets, get rid of everything that's outside the brackets first. So we're not using our three rules yet, our three basic rules, right? Because we've got brackets, we've got to do something else before we tackle those three rules. Okay, get rid of what's outside the brackets first. Okay, what's outside the brackets here? T. So we're going to divide it. D over T equals VI plus VF over 2. There we go. Good? Now, this is tricky. Because we say you want to get rid of what's not attached, right? What's not attached? VF, right? But that's not what we get rid of first. Because if you look at the second little note here, it says, if several terms appear in brackets and you're trying to solve for something that's outside the brackets, sorry, that's the wrong one here. Okay, what we want to do here is treat everything inside the brackets as one term. That make sense? VI and VF become one term. So now we got to get rid of a 2, and we're going to say 2 times D over T equals VI plus VF. Now we can follow the rules. We can go back to those basic three rules. Get rid of what is not attached. VF by subtracting 2D over T. Subtract VF. So rule of thumb here is this. Follow the 3 basic rules. That's going to allow you to solve the vast majority of them. But if you can't do that, because if you got something on the bottom, you got something in brackets, then go a little bit further and follow those notes here.